Hey, this is Mr. Ryan going over the Math 5 quiz number 9, Chapter 5, Sections 1 to Chapter 5, Section 2, taken on January 18, 2019. Make sure to show all your work and box your answers. Determine algebraically whether the function is even, odd, or neither. Algebraically just means that substitute negative x for every x. So I have f of negative x equals negative 3 times x, should be a negative x to the fourth minus negative x squared. So basically what I'm doing there is I'm replacing every x with a negative x. And now here you're just going to simplify. Remember, you're going to use PEMDAS. So that becomes... This is just saying you're putting in the negative x into your function. And then this tells you you're going to do exponents first. So this becomes negative x to the fourth. Negative x times negative x times negative x times negative x. Negative times negative is a positive. Positive times a negative is a negative. Negative times a negative is a positive. So you're going to get x to the fourth. So here this means negative x times negative x, which is positive x squared, and you have that negative there. Now if you recognize what you have here, this says every time you see f of x, you can write negative 3x to the fourth minus x squared. And we have negative 3x to the fourth minus x squared. So instead of writing that, we can write f of x. You're doing a substitution here. What does that mean? When we put in negative x, we get the original function, and that is a even. So even is your answer. Question number 2 says to simplify. A little bit hard to see. You have r minus 7 and r plus 2. I'm going to multiply first, and then we're going to add or combine like terms. So this would give me r squared, 2 times r is 2r, negative 7r, and negative 14. So I have this right now. And then I'm just going to combine like terms. So I get r squared minus 5r minus 14. And this would be choice A. Question number 7 says to simplify. Let me show you the common mistake. So I'll say don't do. A lot of students will try to take this 2 here and try to distribute, and you'll get something like b squared plus 49. So this is wrong. What does b plus 7 squared mean? The exponent there tells you that you have 2 of them. And then you can just use your area model to multiply. B plus 7, B plus 7. Same thing you did above, multiply. So you'll get b squared plus, these are like terms, so that'll be 14b plus 49. And that'll be choice C. Question number 3 says using a graphing calculator to find the relative minimum and maximum and zeros of y equals 3x to the cube plus 15x squared minus 12x minus 60 if necessary round to the nearest hundredth. And the graph here says you do not need to graph it. This graph will not be great. So I'm going to pull up my Desmos. There it is. And I'm just going to type it in, see if I can use my trick. 3x cubed plus 15x squared minus 12x minus 60. This is what my graph looks like. so not kind of what I wanted. So even if you did something like this, it's kind of big, right? So okay, I'm going to make a quick sketch because that just helps me. And this is what it looks like. And then relative minimum. The relative minimum would be here, relative minimum. And if you click on your graph, you get that number, 0.361, comma, negative 62.236. And this would be my relative maximum. So you can click on it, negative 0.69, comma, 37.79. And it says it wanted the zeros. Zeros means where it crosses the x-axis. So that would be comma 2, comma 0. Negative 2, 0. And this last one, negative 5, 0. Let's look at our choices now. I'm looking for a relative minimum at 0.36. So this one matches. A relative max at negative. And zeros at 5, negative 5. So the x values are negative. That's a y value. So x is negative 5, negative 2. 2, so that would be B. A mix, they mix match them, so they said this was the relative what do they do? Oh, they switched the x's and y's. This one has only 2 of the zeros. There's 3. 1, 2, 3. Question number 5, multiple choice, factor completely. I guess that's wrong. You don't need to factor completely. Write the polynomial in the standard form, then name the polynomial based on its degree and number of terms. So just combine like terms. That gives you a negative. Let's see, double check. Looking at mine. That is a negative 11x, and this is a positive, so that would give you a negative 5x squared. Negative 8x plus 2. And so not one of these. And then a minus and a plus 2, and this is a quadratic because of the highest degree, and it's a trinomial because that means 3. There's 1, 2, 3 terms. Friends algebra 12, turn to the backside. I told you guys I didn't have to do this problem, but I'll just demonstrate to you guys how do you do it. X through there, so I know now to count it. And as I draw this box, I have the reason why I have 2 spots here is I'm going to put 9y minus 1. And the reason why I have 3 boxes going across, 1, 2, 3, because I have a trinomial, 1, 2, 3. So let's write that. It is possible that your box looks like that, and that would be fine. Alright, let's multiply 54y to the third. Negative 9y squared. Negative 36y. Negative 6y squared. Positive y. And positive 4. And the neat thing about this is you'll see that as long as you're not missing any terms there, the like terms go diagonal. Show that to you. So I have 54y to the third. And once it gets a lot busier, then I start checking things off. That helps me. These are like terms, so it's negative 15y squared. So I'm adding the numbers in front. Negative 35y, and then this plus 4. So I did these and these and that. So I have 4 terms. That looks like my candidate. Double check. Negative 9y. Yeah, I'm going to go with B. C had positive 3y squared, so maybe that maybe you thought that was a positive, and you add those, and that will give you a positive 3. So we're basically going to do the same thing for question number 7. So I have two terms, 1, 2, that's a binomial. Let's show you guys. Let's do a little bit different. 5x minus 3, and then over here I have x squared minus 5x squared plus 2. And I'm just going to do the same thing. We're going to multiply first, and then we're going to add. So let's write that. Multiply first, and then add. That becomes 5x cubed, negative 3x squared, negative 25x squared, 15x, 10x, and negative 6. So if I put all these down here, and if I just combine like terms here, so 5x cubed, these two are like terms, that's negative 28x squared. These three, that'd be 25x and minus 6. Remember, when you're adding like terms, you're only adding the fronts, your coefficients, you're not adding the exponents or anything like that, because you're just adding. Multiplying, same base, add the exponents. So here's our answer. Make sure to box it. I'm going to mark you off. If you got everything in the boxes, I would have given you 3 points. And then if you got this answer, 4 points. So if you made a mistake and combine like terms, then take off a point. Can fill in the squares so that each row and column contain the number, all the digits 1 to 4. Numbers in cages may repeat as long as they are not in the same row or not in the same column. So I have my freebie. This is a 1 because there's no math operation. This one is a freebie, no math operation. I'm going to start here. 2 numbers that multiply to be 4. You can choose 2 and 2, but you can't repeat, remember, in a row. So it's going to be 4 and 1. So I'm not going to pick 4 here. I'm going to put a 4 over here. So that'll be 4 times 1. Let's look over here. 11. 3 numbers that add up to 11. If you pick the largest numbers, 4 and 4, that would give you 8. And then 11 from 8 would be 3. So I would have to do something like this. I can't put 4 and 4 here because they're repeating in the column. Can't put 4 and 4 because they'll be repeating in the row. So I would put the 4s in the corners. And that would give you 7 plus 4 is 11. Okay. Now if you look at what's happening here, I'm only missing the numbers 1 and 2 in this row. So should I put a 1 here or a 2 here? I'm going to put a 2 here. Because if I can't put a 1 here, because that would be repeating in the column, so this would be a 2 and this would be a 1. So now I have the numbers 1 to 4. I need 3 numbers that add up to 6, so that's 3, so I just need a 3 there, and you know that because you're missing a 3 there. Missing a 2, and we're missing a 3. 2 numbers that add up to 5, that would be 3 and 2. There's a 3 there, so I have to put a 2. Missing a 3, and then missing a 1, missing a 2, and those add up to be 3. Question number 9, multiple choice. What is the graph of the x cubed plus 2x squared minus x squared minus x minus 2? So here, this is a odd degree polynomial. So the easiest odd degree polynomial we know is x to the first, and it looks like this. Starts down, ends up. Here, also in front, there is no negative sign. So they call that your leading coefficient. Leading coefficient. And if it was a negative, it would have flipped these, but it doesn't. So I'm going to eliminate b, because b isn't even. Evens kind of have starts up, ends up, and you notice it kind of has like 2. I don't know if that works. No, it doesn't. I was going to say it has 2 e's, and so that's, I don't know. But evens have the same direction, so I'm crossing that one off. Okay, so I now have 2 polynomials here. These are all odds because they're in different directions, the arrows. And I'm going to eliminate these 2 because these would be cubic functions if they had a leading coefficient that was negative. They would basically switch those, and then you would have like starts up and then ends down, which is these. But that's not the case because our leading coefficient is positive, so our answer is graph C. That's question number 10. Using the graph in question 9a, so I'm going to put my finger at it, this one, fill in the blank for the end behavior. Remember, for end behaviors, you are always having the beginning start like that, always. Look for the x's. Sometimes they switch these. And basically it says, as x approaches positive infinity, what's happening is this is positive infinity. Let's use a darker color. Might be helpful for you. On the x-axis, these are positive numbers. We call that positive infinity because way over there is a big old number. And to the left are negative numbers. Going down on the y-axis is negative, and this is now positive. So as x approaches positive infinity, that's going this right. The x-axis, so this is going towards the right. What's happening to the graph? On a roller coaster, it goes down. So going down on the f of x, f of x is the same thing as saying the y-axis. What's happening to our graph is it's going down, and that would be called negative infinity. So that's another way of saying down. As x approaches negative infinity, so that's actually going from right to left. So I'm just going to write going left. So going left, what's happening to our graph? The graph finishes going up. Going up means positive infinity on our f of x. And the front side, back side was 16 points, and then yours is out of 28. Hopefully this was helpful for you. Good luck.